Okay, what's up, geometry? Put together a little video here to give you some examples on this next lesson. There's a couple of questions I'm going to skip. But hopefully this will be a help to you, okay, to be able to do these questions. Okay, so you need to really study. I'm not going to take the time, but you need to just read over this theorem a few times and let it sink in what it's saying, okay? The ratio of the areas of two similar polygons. So the ratio of their areas is equal to the square of the ratio of the lengths of any pair of corresponding sides. Okay, so remember with similar polygons, that means that's not congruent, right? That's similar. So you're going to have one that's larger than the other, but they're gonna be proportional, right? They're gonna be proportional. Okay, so one of the things I wrote down, I wrote down my this paper at the bottom here. Okay, so if we have the ratio of two corresponding sides, then we square that ratio to get the ratio of the areas. All right? So if we want to write that down, if we have the ratio of two corresponding sides, then we square that ratio to get the ratio of the areas. And you're going to see a problem or two, maybe three, that deal with this. If we have the ratio of the areas, then we square root that ratio to get the ratio of two corresponding sides. So we work backwards, okay? So if you have the ratio of the areas, then you're going to square root that ratio to get the ratio of the two corresponding sides, all right? So let's look at a couple of examples here, all right? So you got two similar polygons, and they have areas of 50 and 150 square inches, okay? Find the ratio of the length of a pair of corresponding sides. So let's just say that these polygons are two rectangles, okay? All right. Okay, and it already says that they're similar, so we know they're proportional, all right? So the area of one of them is 50 inches squared, and the other is 150 inches squared. All right, so here we have a ratio of the areas. That's 50 to 150. Okay, now that reduces down to 1/3. Okay. Now look at the theorem again. The ratio of the areas of two similar polygons is equal to the square of the ratio of the lengths. Okay. Well, remember what I just told you. I showed you on that other paper. If you have the ratio of the area, if that's what you have, then to find out what the ratio of two corresponding sides are, is you're gonna square root this. Okay, you're gonna square root this ratio. So this is gonna actually break down to the square root of 1 over the square root of 3. It's how you can break that down like that. Okay. All right. So now remember, you can't have a radical in the denominator. All right, now let's go ahead and simplify this. So we know on top the square root of 1 is just 1, so then we have 1 over the square root of 3. Okay. Now we can't leave this here like this. So we need to rationalize the denominator, and we need to multiply it by something. Okay, so what can we multiply this by to give us a result that is a perfect square? Okay, well, if I multiply it by the square root of 1, I still get the square root of 3. If I multiply 3 times square root of 2, I get the square root of 6. Square root of 6 is not a perfect square. So I'm going to multiply by the square root of 3. Because what that gives me is the square root of 9, which is 3. And on the top, I have 1 times the square root of 3 is just the square root of 3. So what we end up with is the square root of 3 over 3. Okay? So I don't know if that if that makes sense. I'm telling you, you're going to need to read that theorem through, a couple of times.